Good. So, hi. My name is Niels, and this talk is about JavaScript on microcontrollers. All right. Doesn't work. No matter. And it doesn't work. Let's try again. Yes. All right. Today we're going to talk about JavaScript on microcontrollers, and usually this talk is about 45 minutes long, and we just have 25 minutes, so I have to talk really fast, or cut out some stuff. So I removed all the jokes and the funny things. I'm sorry. This is just the boring stuff. Don't worry. This is going to be fine. This is the meat of the talk. It's the good stuff. I promise. So anyway, I'm a Mozilla Tech speaker, and I'm a Google developer expert. I tweeted HTML5 tests, and I love electronics. So when I was a teenager, I had this cardboard electronics set with all kinds of different components. There it is. And you could clip wires between springs, and you could build a radio or a Morse code transmitter, and it was just absolutely fantastic. And this is what I have now. It's basically the same thing. Still components that you connect together with some wires, and they have become much more advanced. Instead of transistors and diodes and resistors, we now play with microcontrollers and all kinds of sensors. And everything still works together. But I am a web developer by trade, and I program in JavaScript. So programming microcontrollers is usually done in C, and I don't want to program in C. I want to program in JavaScript, because I know JavaScript. So what if we could leverage JavaScript, or program microcontrollers in JavaScript and leverage the browsers to connect these microcontrollers to the web and let them extend each other's capabilities? Now, that is all fine and well. But microcontrollers are slow. They are really slow. And when I say slow, that really does not even convey the idea of how slow they actually are. They are slow. So take, for example, the Raspberry Pi. This is the 0W. This is not a microcontroller. This is a computer. And it runs Linux and Node.js and can run a browser like Chrome or Firefox. So this is not a microcontroller. This is a microbit. It's a little board for school children, and it runs at just 16 megahertz, has only 16 kilobytes of RAM, and it is slow. But it's not even by far the slowest microcontroller you can buy. But this is fast enough to run JavaScript. So to put in context, the Raspberry Pi is about 60 times faster than a microbit, and it has way more memory. So the microbit is on a completely different level. But running JavaScript on microcontrollers is actually pretty brilliant. Microcontrollers are actually very power efficient. You can run JavaScript on a tiny little Bluetooth-enabled board and power it using a coin cell battery. And it can run for months. So slow is a good thing, because when we make things faster, they tend to require more power. And microcontrollers are fast enough. Yes, they are slow, but we only have to solve very tiny problems. So microcontrollers are fast enough for everything I'm going to show you today. Yeah, you can't run React on it. But yeah, I wouldn't run React anywhere anyway, so. So that's the one joke. So let's take a look at how we can get JavaScript on our microcontrollers. So there's actually an open source project that allows us to do this. It's called Espruino. It's created by Gordon Williams. And you can also buy hardware with Espruino already installed. Actually, Gordon is here with a stand in the AW building, I think. So check it out. But there's also versions that you can flash yourself on your own hardware, like on ESP32 and ESP8266 microcontrollers. It is an interpreter that supports most of JavaScript, even some ES6 features like arrow functions and so. And it has a REPL functionality. So you can connect it using, to the computer using a USB cable or Bluetooth, and you can execute commands on the microcontroller, just like you would in the console of a browser. So now it's time for the demo. I hope. Because, yeah, this is, well, I have some warnings to give. This is cutting edge stuff, hardware demos with experimental technology, and most of it is using Bluetooth, which is a wireless connection, and Bluetooth uses the same frequencies as Wi-Fi, and this is a room full of Wi-Fi devices. So there's a lot of opportunity for interference. So this is the moment I usually get nervous. So, yeah, okay. We're going to create some stuff. First of all, we're going to create a connected light bulb in JavaScript, running on a microcontroller. And to do that, we need some hardware. We need a NeoPixel ring. This is basically just 24 LEDs that can change to any color you want. You can individually address them and change the color of each of the LEDs. It's connected with three wires, and one for power, one for ground, and one with the data for turning on LEDs. And it's connected to a tiny little microcontroller. It's not that big. This is actually an ESP32, and I flashed it with Esperino, and basically that means we now can make it a connected light bulb. So let's try this. Right. Let's see if this works. Yes. So when I apply power to this thing, nothing happens. But that's okay because I haven't programmed it yet. So that's actually what I expected. So let's start with, let's take a chair. Let's start with some code. So I'm going to need a color. So this is just a hex representative of any RGB color. In this case, FF9900. And we need a buffer. In this case, we have 24 LEDs. And for every LED, we're going to save an RGB value. So 24 times 3. And we're going to set that color into the buffer. Now, the problem is these LED rings are a little bit weird. They think GRB is the right order for RGB. Well, that actually depends on which ring you buy. Sometimes it's also something completely different. It's never RGB though. Yeah. So finally, we need to write our buffer to the data pin. Let's connect to the device. Do we have it here? No. It's not here. Try again. and it can't find it. So I have a problem, but I have a backup, fortunately. There it is. So when we write that value to the NeoPixel ring, to the D15 pin, it will light up. So I pre-programmed this one so that it's actually cheating, but we'll continue anyway. So what we'll do next is we're going to skip some stuff. So what I'm doing here, I still have the color, I still have the buffer, except I'm using a function called update, and we're gonna fill the buffer with the color again, and then I'm gonna write it to the D15 pin and call update. It's the same thing. Now, what I do then is I use a special event called an init event, and whenever the board turns on, that callback is called, and we're going to advertise our light using a special name, an Esperino light. We're going to advertise it using Bluetooth. After that, we're going to offer some services. These are kind of like IDs or basically the URL endpoint of our Bluetooth API service. In this case, it's FFFA, FFFB. Now, when we make this readable, that means we can use a different device to read the color. And when we make it writable, we can use a device to write a color to it. The default value is our RGB color. And whenever we write something to it, we're going to update our color here with the new values and call update. So this is 29 lines of code. And with these lines, I can make this light bulb connectable from a different device, from a Bluetooth device. So let's see. I do quickly So let's try this. So what we're going to do using the browser, using the web Bluetooth API, connect to this device. So we again have this FFFA ID, and we use the Esperino light name as a filter. And if everything works, we have our light here that is being advertised. We pair with it. We get our device, then we can connect to the GTT server. That's details, don't worry about that. It takes a bit longer than I'm comfortable with, but there it is. And we get our service. There it is. And then we get a characteristic that is FFFB, and that is the one we're advertising here. And with that, we have a value that we can write to. So we can write any value to this color, or to this device, like FF0080. And it turns pink. But we can change it to any color we want. We can change it to blue, green, basically any color, any RGB value we want. And we did that with just 5 lines of JavaScript in the browser and 29 lines of JavaScript running on a microcontroller. So I think this is pretty amazing. But we can do more. With those 5 lines, I can create a web app, and I can just make it pretty. I can turn it black. And even I can run CSS animations on it. Yeah, okay. Anyway. I do have one more demo to give, and that is using a remote-controlled car. And this car is, it has a microcontroller, it has a motor board, and there is no soldering involved in any way. It's just put together and added some wires, and that's it. I'm going to drive it today, I hope. And it's, yeah, it works. So let's get rid of this. Connect to the car. And write some code. We need a function to drive the car. We want to turn left, we want to turn right. That has 2 motors. If we want to go forward, we go both motors full on. Backwards, both motors reverse. So these pins here, those are determined by the motherboard I'm using. And this is basically all the lines of code you need to make it drive. But to make it stop, that's also very useful, especially on this table. We need another function. And a little helper functions is also pretty nice. Forward, reverse, left, and right. So with 17 lines of code, I can now make it go left. And I can make it go right. And I can make it stop. All right. Okay, this is good, this is good. So, again, we can make a prettier demo for this. So, there it is. Somehow today we're having some issues, but we'll try again. There it is. So now I can use the arrow keys to drive it around. So, but what I haven't told you is that I can actually drive this car off the table. Because of, well, I can drive it off the table, I can try, but it will refuse to do so. Because of lasers. Well, actually a little tiny laser that's right mounted here on front, and it measures the time of flight it takes before the laser to reflect back. And we can add that to our code. Well, make it. So we have to measure distances, and when the distance is over a certain threshold, we are not yet in emergency mode. We're going to turn on emergency mode and reverse. And when we're clear again, we're going to cancel emergency mode and stop. And we must not forget to actually initialize the sensor, because otherwise... and this should do it. So, important thing. So I did this talk in Phoenix a week or two ago in Arizona, which is, well, I used the American flag. And it actually drove off the table. They didn't kick me out of the building immediately, fortunately. But yeah, I probably won't do that again. But here in Belgium, we're safe. This is fine. But yeah, to be honest, about 80% of the time this works. Okay.